Hi, Bill Scott here. Got another episode documenting a project I've been working on sort of off and on for the past few months. And the idea here was really inspired by a video that Jeff Highsmith put together. I'd highly recommend searching on YouTube. Mission Control Desk, Jeff Highsmith, just incredible work. And it got me thinking. I've got two young daughters, and got me thinking about the idea of cooperative games as opposed to competitive play. And this was one idea. I thought space exploration is a nice way to sort of merge two different types of interest or groups of play. So anyway, this is where the idea came from to put together this spaceship, bedroom spaceship with a mission control type arrangement. So I'll walk you through panel one in episode one of Bedroom Spaceship. Okay, so here is a basic sketch of the design, sort of what I was thinking before I started going on the spaceship panel. So essentially, what we did, my daughter and I walked through the basement and the old electronics bins and looked for cool stuff for making a spaceship panel. So she's a big fan of lights and not a big fan of sounds. So we ended up with a lot of LEDs, a lot of switches, and trying to make it seem like a somewhat realistic spaceship with labels and such, but really a lot of fun for them. And my dad used to be an electrical engineer, and so most of this stuff was left over from stuff that he'd done and projects that we'd done over the years. I used to love taking stuff apart as a kid, so lots of piles of switches and potentiometers and stuff left over, just waiting to be turned into a spaceship. So what we have here at the top left is the power switch, and I split it into two rails. So this is the power for the top rail. So we can switch these off and on independently from the bottom rail. And I built these in modules. So I sort of put together this one, tested it on its own, make sure that the voltage was in a reasonable range for the LEDs, and then saved that and then assembled it all and tested it all at the end together. So what we have here is four LEDs, power coming in on the top through the LED, through a sliding potentiometer, through a resistor to ground. And most of these resistors are 220 ohm. Most of the LEDs want somewhere between 2 and 3 volts, but it depends on the LED. And most of these were mystery LEDs in bags, so I wasn't really sure going in just exactly what they wanted. So some of these resistors are different, but that's really the experimentation phase. So I didn't calculate anything here. Not to say this is the best way to go about doing it, but based on the risk and sort of the worst case, burning out an LED and just getting a new one. So nothing here is over 5 volts, so not as many safety concerns as if you were to go with higher voltages and things like that. So wired up this module and sort of set it aside, make sure it was ready to be installed, and did a similar thing here. So we have four LEDs again, power on the top rail, and then four switches through a resistor and to ground. And I simplified the drawing of the switches just to make things simple for this explanation. The second bottom rail here. So a little bit more complicated in the middle section here. I never really understood how these 7-segment displays worked, but they're everywhere and it's kind of neat. There was a pretty good YouTube video. Ben Eater goes through how they work and how to wire them up. That was really helpful. So I went through and wired these all up so they display nines. Just 9 volts seemed appropriate and 99% battery capacity. But in the future, I'll wire these up so that they change. For now, I just thought get the lights turned on and see if the kids like it. We can always add complexity later. So the way this works, power comes in on the top rail through the switch and then through the resistor coming out the bottom. So each of these lines is independent of each other and controlled by this switch. And the fourth sort of module here, not shown, is the keypad on the front, but my daughter really liked this keypad. So That goes into the Arduino, which reads the keypad and then displays it here for the launch keypad. And it seems a little bit unfair, I guess, to just use the Arduino as a voltage regulator to take 9 volts from the battery and send 5 volts out for the board. So it does have some functionality in the keypad, but plenty of room for future expansion as well. And the power switch to turn the whole unit on here essentially just cut into the battery connector and wired it through this switch. So we can turn it all off and on here and turn off the top rail independently, just in case there were current issues. I notice it if this battery starts to die, then I can turn the top rail off or let it boot up and then turn the top rail on. So that's basically what I had less than this going in at the beginning, but that's essentially a nicer drawing of my basic design idea. I took a piece of MDF that I had lying around, punched some holes in it, and assembled the components. So I'll show you what that looks like. All right, so once all of the individual modules were built, I put them into the MDF and wired them up on the back. So essentially what that looks like is the battery comes through power switch here into the Arduino. 5 volts comes out of the Arduino and feeds this rail here. And this power comes off and goes up through the switch on the top rail. That goes through the top of the LEDs, here. That comes down and goes through this set. And 5 volts also goes to the display here. And we need that power to come back somehow. So these ones get wired up like this. Ground's connected here. And then this comes up here. So something like that. So the power is coming in from the battery, going to all the modules, and then it has to come back somehow. So we connected up all those grounds and back to the Arduino. So something like that. So this is the front side of Spaceship Panel 1. And as I kind of look at this, two things occur to me. Sometimes I get overwhelmed with design constraints. So one thing with projects like this, I really like to try and not spend any money and just use stuff that I can find in the basement. The second thing this makes me realize is I have a hard time throwing out things that look like they might be useful on a future project. So that's part of what you're seeing here is really a collection of things that were hidden in boxes, stuffed in the basement, and now are getting to see the light of day. So up here, a few rocker switches, pretty satisfying sounds as we go through here. And so just kind of spacing wise, trying to lay it out rough on the front, sort of trace it out here and then drill the holes. And that was probably the trickiest part, is to get the spacing just right. Obviously, MDF is a little bit more forgiving than something like aluminum, but I didn't really want a whole lot of holes lying around where they shouldn't be. You can see these straight sections were a little bit harder, and after a while I gave up trying to be really clean with them and just kind of push the holes through. These handles were for some, I think they were from my old kitchen cabinet drawers. And then the launch code keypad did not inset very nicely, so it has an electrical tape barrier around it. Keypad, though, works pretty well. Pretty decent YouTube videos on how to wire up keypads. Again, I see them everywhere. I didn't really know how they work until I had to program it myself. So it's pretty helpful to have a tutorial to walk me through. Saved a lot of time. And then these 7-segment displays. Also pretty neat learning how they worked. So that's essentially panel 1. We put the flight console in here so we can track the International Space Station. Seems pretty legitimate. And then weather station over here. And away we go. And so this is the backside. So it's flipped from what we saw previously, but it's more like the drawing. Power switch here. I tried to use red to be 5 volts, black to be return or ground, and yellow. I guess I've got yellow and blue for some of the switching. So the power, see this, the power basically starts here, the battery, goes into the Arduino, comes out of the Arduino into this rail here, and then makes its way up to, so there's a switch for the bottom rail here, and then this one makes its way up to the top, so we can switch it here, and then that provides power to this top rail, and black ground coming down here, and we're bringing power across. So these ones are flipped, so the top rail's on the bottom in this case, and then the ground coming off here through black, back down to here. And this is where most of the complexity is in terms of soldering. It might be kind of hard to see, but these were kind of fun to wire up. I think once you're getting into programming them to change, the programming gets a bit more complicated with interrupts and things like that, or you run out of pins to turn them off and on. So that may be the next project, to wire all these up so they can be controllable. But essentially that's what went into this one. So flip it back over and show you the finished product, and then install it in the Spaceship and do our commissioning tests. So this is what the finished product looks like. We've got space station tracker in the middle. We've got our power to main and auxiliaries. Eventually we've got motor power here, mission control time compared with our time, launch keypad equipped with some sort of, just see it there. So random sequences pop in to be entered into our launch keypad here. We've got bus voltages and percentage battery capacity, and our weather station, which doesn't show up too well unless you're looking right at it. But these, the weather station sensors are in the garage right now, so we can move those around and get different conditions. So hopefully you enjoyed this. Stay tuned for part 2, where we install it in the bedroom spaceship. Thanks for watching.